Yeah, okay. Simple harmonic motion is defined as follows. Yeah. A body executes simple harmonic motion if its acceleration is directly proportional to its displacement, yeah, from its equilibrium position. Yeah. And in the opposite direction, it's to displacement. Ini, if I draw it, this is like when they have, yeah, this is equilibrium position. Yeah, this is equilibrium position, equilibrium position. So they have acceleration, yeah, is directly proportional to its displacement. Yeah. Yes, setengah dari tadi. Sorry. Okay. Yeah. And from its equilibrium position, this is equilibrium position, yeah, and its opposite direction to its displacement, and its opposite direction, ya. Ini selalu opposite. Kalau kita lihat, ya, this acceleration, this one. Hmm. This is the formula, yeah, this is the formula. A equals to minus omega square x, ya. Uh, Kalau boleh Bapak turunkan gini guys, ya. Nih, seperti fungsi yang kemarin saya bilang, ya. When we have x as the function of sinusoidal function, ya. Yes. Astaga. Okay. Sorry. Okay. No. I repeat from function. Yeah, function. Yeah. When we have x, yeah, as the a sine omega t. Yeah. And then we know velocity or v equals to the x over dt. Now, so when we differentiate this formula, it's become a, yeah, minus cos omega t, and then omega t we differentiate again as omega. So we have v equals to minus a omega minus, yeah, minus omega a cos omega t, yeah. This is the formula of velocity. So what about acceleration? Acceleration is dv over dt, yeah. So when we differentiate about v, yeah, this is constant, yeah, omega a. Then cos, yeah, cos, differentiate cos equals to sine omega t, and then differentiate omega t is omega, yeah. So this is like times with omega. So we have a equals to minus omega times omega square, and this is a sine omega t. Then we work again about x, yeah, equals to a sine omega t. So a sine omega t on this equation we can change into x, yeah. So a equals to omega square x, yeah. This one. Okay. This is what formula, same thing with uh, ini ya, this one ya. Nah, kalau okay. Yeah, what I mentioned before about relationship between position, yeah, velocity, and acceleration as the function of differentiate and integrate. Yeah, this is we differentiate. Oh, we differentiate. Yeah, this one. That v equals to dx over dt. Yeah, and then acceleration equals to dv over dt. And back reverse, yeah, that x equals to integrate, yeah, integrate of v dt, and also v, yeah, v also integrate of a dt, yeah, a as integrate of v, sorry, terbalik, v integrate of a dt, yeah. V is integrate of a dt. Seperti itu ya guys. Okay, if you want to copy this, I will wait about 3 minutes, maybe, yeah, 3 minutes, and we back. We continue to the next page. Okay, that's it.
Nggak ada sayang, habis.
Okay, yeah, I think enough. Then we have graph, yeah. I zoom first, yeah, about graph relationship between a and x. Yeah, you may see this. Yeah, this is on the y axis as acceleration. On the on the x axis is x. Yeah. So they have graph as the gradient is negative. Yeah. So slope is like going left. Yeah. This one. Yeah. So we have gradient as the minus omega square. Yeah. Relationship between x and a. Yeah. Between position and acceleration. Okay. This is already I break down or I differentiate from x here, and then this is also we have other equation. Then okay, this is we can use this is omega ya, v ya, v sama dengan omega x ya, v omega omega r ya. Then let's try see question here about number. We see first here number 16. Okay, number 16 ya. Let me check number 16. I zoom out first. Mudah-mudahan bisa kelihatan ya. Oke. Kita tulis plus ini. Or di sini bisa nggak ya? Oh nggak bisa. Wait. Oke. Sini. Number 16. Ya. A mass secure at the end spring move with S.H.M. The frequency motion is, okay, we have frequency as 1.4 hertz. 1.4 hertz. Yeah. Write an equation A, yeah, equals to minus omega square x to show how acceleration the mass depends on the displacement. Okay. Only we put frequency on the equation, yeah, but equation we need to change in other equation, yeah. Okay. A equals to minus omega square x, yeah. Then omega is 2 pi f, yeah, and then square 2 times x. So when we put this is something with 4 pi square f square, yeah, 1.4 square x, yeah. So bisa kita tulis mungkin minus ya, kalau kita kali. I put calculator first ya. Hmm, 1.4 square times 4 equals to 784. 7.84 pi square x, yeah. So or if we change pi square into 3.14 square, yeah, 77, this is like
Kak, tolong kuncinya nak.
minus 77 point maybe this is 2993, yeah, in x, yeah. So we can see this is acceleration of the mass depends on the displacement, yeah. Acceleration of the mass depend its displacement, yeah. That's it. Okay. Okay, let me check about B question. Yeah. Calculate the acceleration of the mass when displayed 0.05 x from the equilibrium. Yeah. B, this is equals to A, yeah, minus 77.3 times x is 0.05. Oh, yeah. So A equals to 0.05, 3.86. Yeah, this is about 3.86, negative 3.86. Yeah, in meter second minus 2. Yeah, yeah, that's it. Ya, seperti ini ya, guys. Okay, we check number 17 maybe. Yeah, I will uh, zoom in, zoom out. Sorry. Yeah. Now, I hope you still can clear see it. Yeah. Okay, we check number 17 here. A short pendulum oscillates with S.H.M. Yeah, simple harmonic motion such that its accelerate A in meter second minus 2 is related to its displacement x in meter by equation A equals to, or they have equation minus 300 times x here. Determine frequency of the acceleration. Okay, frequency is coming from omega, yeah. So you know A equals omega square x, yeah. So it's mean omega square as 300, yeah. Omega square is 2 pi f, yeah, equals to, so from this, yeah, this is something with root of 300 divided by 2 pi, yeah. So after we calculate this, root of 300, yeah, and then we divide it by 2 pi, yeah. Uh, this is 2.75, 2.76, yeah, we run off. This is about 2.76 in hertz, yeah, yeah, that's it. Okay, this is number 17, and we get answer as 2.76. Okay, I think one more number uh, 18, yeah, we try number 18. Number 18 here. The pendulum is a grandfather clock swing one side to other in 1.0 second. Swing from one side to the other. To the other, yeah, to the other, not back in the same position. So this is like period is 2 times of 1.0 second. Yeah. So period equals to 2.00 second. Yeah. Because this is to from side to other, yeah, from side to other. So same thing with a half period. The amplitude of oscillation 12 centimeter. Yeah, we have amplitude 12 centimeter, yeah, or 0.12 meter. Yeah. Okay. This is amplitude. So from this, some several question. Yeah. Calculate the period of its moment. Oh, period tadi sudah ya. Period equals to 2.00 second. And then the frequency is 1 over 2.00 equal to 0.5 hertz. Yeah. And then angular 2 pi uh, f, yeah, 2 pi 0.5. Yeah, so same thing with pi, yeah, 3.14 in radian second minus 1. Yeah, okay. And then B question, we see B. Yeah. Write an equation of form A equals to minus omega square x to show how the acceleration of pendulum weight depend on the displacement. Ya kita ganti aja, we change ya, as acceleration minus omega square. Omega we have this pi square ya, 3.14 square x. Yeah. So A equals to 3.14 square 9.85 negative 9.85, yeah, x, yeah. So we have this apa namanya, equation ya. Okay, what about C question? Yeah, C question we have calculate maximum speed of the pendulum bob. Okay, V equals to, we have formula A cos omega T. Yeah. Oh sorry. Uh, A omega ya. Salah apa sih? Salah. Harus kita. We have V as negatif. Aduh, kok salah lagi papan nulisnya. Negatif E omega ya. E omega cos omega T. So when they ask me about V maximum, yeah, yeah, this is equals to when cos theta equals 1. Yeah, same thing with A omega. Yeah, so V maximum equals to A is 0.12, yeah, 0.12, and then omega is 3.14. Yeah, so equals to, with, oh, -0.37. Negative 0.37. Yeah, this is in meter second minus 1. Okay. C, yeah, okay. Now, and calculate the speed of bob when its displacement is 6 centimeter. Okay, uh, I will close about question ya. I need space to next answer, so maybe seperti ini ya. Bapak kira kalian ada itunya soalnya. Kita di sini when x equals to 6 centimeter, so v equals what? Um, wait, we find from, oh, we find about sin cos tangent first, yeah. Okay. Hmm. I use this x equals to a sine omega t, yeah. So when x6, this is 12 in centimeter, yeah, equals to sine omega t. So we have sine omega t equals to 6 over 12. This is 0.5. And then cos omega t equals to uh, omega t means 30 degree ya, 30 degree. Kalau Bapak ganti dulu omega t ya equals to 30 degree. So cos omega t equals to setengah akar 3 ya. Cos 30 itu 0.87, 0.87. Ini tanggungnya, lanjutin dulu. This 0.87. So from this ya, Bapak sini dulu. Ya. V equal back again but formula A omega cos omega t. We have A is in meter 0.12 and then omega is pi 3.14, yeah, and then cos equals to 0.87. So V, yeah, equals to, yeah, times again 0.326. This is equals 0.32633, yeah, we don't know 33 now in meter second minus 1. Okay, done. Yeah, this is for number 16, 18. Yeah. Uh, okay, if you want to copy this or write this, please take copy. Yeah, take a note, and maybe I will wait a little bit long. Yeah, maybe I will wait about 10 minutes. Ya. Silakan kalau mau ditulis, Bapak tunggu sekitar 10 menitan.